In this lesson, we'll look at some box plots and how to compare different data sets. So I've got here an image of what a box plot looks like. Okay, so indicates the lowest score, so the minimum, and then the lower quartile, Q1, then the median, which we can call Q2, the upper quartile, Q3, and the greatest score, the max. So it's really a graphical display of those statistics that we've been calculating all the time. Okay, we've also got the 5-number summary, which is essentially the box plot with just the 5 numbers listed, separated by commas. I'm not sure why there's a 2 after that. Okay, minimum, Q1, median, Q3, maximum. So if someone asks for the 5-number summary, you give them those 5 numbers. Here's what a few box plots look like given the distribution of the data. So we say that this is normally distributed data because the majority of the scores are in the middle somewhere, and then there's some smaller and some bigger scores, but not as many. And most things are normally distributed, like your height, your weight, your IQ, all these sorts of things. Okay, and you might know it as a bell curve. Okay, so if we've got normally distributed data, typically we've got the mean and the median about the same point, and this is what our box plot would look like. For clustered data, okay, again, it's pretty symmetrical about this point, so mean and median will be about the same. But we can see that there's the middle 50% is very centralized into this small part, whereas we have only a few extreme values on either side. Okay, we've also got data that's reasonably spread out. Okay, so there's no real, there's no peak at anywhere in the data. Okay, again, the mean and the median will be pretty much at the same point, and this is what the box plot looks like. Okay, we can see that the middle 50% of the data is more spread out than in the normally distributed or the clustered data. Okay, these two are probably the most important ones. Okay, positively skewed data, okay, is where I would have a median score somewhere here, and the mean would be bigger than the median because it's being affected by these positive outliers that are bigger than the rest of the data. An example of positively skewed data is income. Okay, as we discussed, looking at that budget announcement, there's some people with lots of income, which would bring the mean up. Okay, we can see what that looks like as a box plot. Okay, the final one, negatively skewed data, where the median would be probably about here somewhere, but the mean would be significantly lower than that. An example of this would be the number of matches, okay, in a box. Okay, so the majority of them would be around about however many there should be, say it's 200 in the box. But in these manufacturing processes, we sometimes have ones that don't get given enough matches in the box. Okay, so we get some negative skew there. Another example you think of is number of uncracked eggs in a carton of eggs in the supermarket. Okay, negatively skewed data has some smaller outliers. There's another one that you can think of as the number of fingers that people have. Okay, the majority of people have 10. Some people have less than 10 due to various accidents. Okay, some people have more than 10, but probably less people than are missing fingers. Okay, so our little rules here. So for normally distributed data, okay, so for any of these first 3, we can use the mean or the median. Okay, it doesn't matter. But for skewed data, okay, the median is preferred because it's less susceptible to the effective outliers. Okay, so in general, we'll use the median, but if it's normally distributed, mean or median is fine. So I'm going to construct a parallel box plot to compare the following classes results on a recent exam. Yeah, that's bad punctuation, whoever wrote this. Class A and Class B. Okay, we could calculate these statistics manually. Okay, you're expected to be able to calculate them manually. Okay, the min, the max, Q1, Q3, and the median. Okay, so we've done that manually before, and you will be expected to be able to do that. Okay, just for fun, we're going to do it on the graphics calculator to see how powerful this graphics calculator is. Okay, so what I'll do is follow these steps. So I'll go into my menu. I'll have to make you a little bit smaller. Okay, so add data to list 1 and list 2. So I'm in stat mode. And I'm going to put my data into both of these lists. So 54, 35, etc. Okay, magic, I've got all the data in there. Okay, and now I'm going to try and make this box plot. So it's a graph, so I'm going to go into this graph menu. And I need to do some setting up. Okay, my first graph, okay, graph 1. I don't want a scatter plot, I want a box plot. Okay, so I choose box plot. Which list do I want? I want list 1. Okay, I'm going to have class A in this box plot. Okay, this all looks pretty good to me. Okay, now I'll go back up to stat graph. I'm going to choose graph 2. This is going to be my second box plot. Okay, and I'm going to scroll down and make it a box plot, but this time I want list number 2. Okay, so that's looking all good. Okay, now I need to select which graphs I want to produce. So in select, I want to graph 1, so draw on, and graph 2, draw on as well. And now I should be able to draw this thing. Okay, and I've got 2 box plots here, which are, what do we call these? Parallel box plots, so we can compare the 2 classes. Okay, the top one is class A, the bottom one is class B. If I want to obtain my 5-number summary, I can press Shift and Trace, and I'll be able to just use the right arrow to get my 5-number summary. Okay, and I can go down to class B as well. Okay, so I'll put this in here. Okay, and what we really want to do is to be able to compare these 2 classes. So there's a few comparisons that we can make. Okay, so first of all, we'll look at the medians. So 54 and 54. So just looking at the measures, the central tendency. Okay, the median score in class A and class B is identical, which would indicate the classes have the same level of ability overall. Okay, we can also look at the measures of spread. Okay, so since we've got a box plot, we'll be mainly just using the range and the interquartile range. Okay, so I'd say the range of class A is whatever it is. So the max 92 minus 12. So 80, whereas the range of class B is 12 to 98. Is 86. So there's a bigger range of ability in class B. Okay, that's what the range is indicating. Okay, but if I compare the interquartile ranges, comparing interquartile ranges, the class A IQR is 46.5. Okay, you can verify that. And class B IQR is 40.5. Okay, so what we can really see, and we can see it graphically here as well, that the main bulk of students, the middle 50% in class A, is spread out a lot wider than in class B. Okay, so we can see that class B actually has a bigger spread of ability when the outliers are not considered. And remember, the interquartile range is the range that doesn't consider any outliers. Okay, like for example, this 98. Okay, see 98, there's no other score anywhere near it. Okay, so that's how the range got affected, but the interquartile range isn't affected by that outlier, and it's probably a better way to indicate the spread of ability. A final thing we can look at is any extreme values, or I guess identify the outliers, and by doing that we can see that, let's look at the minimum values, 12 and 12, they're the same, nothing to comment on. Class B has one student on 98, okay, whereas Class A had one student on 92. Okay, so we can say that Class B has the higher maximum. Okay, 98 versus 92, indicating the best student is in Class B. Okay, so from that comparison, ideally you'd be able to make some comment about the ability of the students in the class, or the ability of the teachers to teach the class. Okay, all those sorts of comments are what we're trying to be able to make. In class, what we'll do is spend a lot of time making those comments, okay, seeing how precise we can get making comments, and we'll have a little bit of a play with back-to-back stem and leaf plots as well. Okay, but the key idea is you need to be able to calculate 5-number summaries, put them into a box plot. Just when you draw these manually, you'll need to draw this axis, and you'll need to mark some points in here. So I'll probably mark from 10 to 90, okay, in 10 score intervals, okay, all the way up there, just like you're drawing a normal graph, so that when you draw it on your page, the person can read off what all these different values are. Alright, that's the last lesson for the term as well, so from here would be revision.